that's always, I'd like to be remembered by someone that, by my family. I'd like to, in terms of science, by someone who raised questions and left a good progeny of students and scholars. I think with rigorous scholars and rigorous the rest, as they say, it's a very good sentence of a Belgian or French developmental biologist called Jean Rostand: theories pass, the frog remains. I really like that one. You can theorize over the frog. The theories, there will be many theories over time, and the frog will remain. We are just adding little things, and if what I can do, it helps the new generations to understand, that's a good thing. I think that that's the most important thing. I mean, the most valuable thing I do as an academic and as a researcher is to raise new questions that feed the curiosity and the intellect of younger people. I think, to me, that is the big satisfaction, and where I draw more of what I really like to do. I think this is a very exciting time in biology. I've been very lucky to do my career in a topic that I was interested in, from a time where we didn't know what genes involve in development, to a time that now we can see that there is more than the genes that control development. And also brings me back to my interest in physics when I went to the University of Chicago and tried to bring that interest into the thing. So very simple, by the progeny that they will remember. And he said, it was good. He made us think in interesting ways. That's really what I would like.
So, Professor, before we close, I want to know, what are some of the questions that you're toying with now, especially some of the questions that you hope either you can address or someone else can address, can solve?
Well, I think two very simple questions. How do these cells, it's interesting because this number of cells that initiate, with which we can initiate the organization of these embryo-like structures in a dish, is approximately the same number that the real embryo has. So what is it in that number? How do cells read that number in a precise manner? We are working on that, to organize themselves.
Is that called gastrulation?
Gastruloids. Gastrulation is the process that takes the mass of cells.
Yes, you talked about that.
And then transforms it through an origami. I mean, my friend Louis Wolpert used to say that the most important moment in your life is not when you're born, when you marry, when you're dead, but when you undergo gastrulation. And I'd like gastrulation to be, because that's the moment where you acquire the shape and the organization that is going to give rise to you. So yes, we use gastruloids for our studies, as so many other people now in the world, and I'm pleased for that. You see, it's a good thing that we generated a tool of study, I think, to generate. That's one thing. The other thing that I'm curious, but I don't think I'll have the time to do it, is what we were talking about. How the same genes generate different tempos, different structures. I mean, what are cells reading? How are they generating time? But this is a question that I don't think I'll ever get to it.
Wait, can you please expand on that question, just so that you can leave it open for people who are younger biologists, and you can also use this as a time to state what your advice is for people who are entering the field. So restate the question about time.
No, the question about time, as I say, there is people now, a small group of people that are tackling this process. How cells keep time. I mean, and also a mouse and a human embryo, for example, they have the same genes, they have the same programs running, but they run at different times. Where is the source of that question? I think this is a very, very important question. The other question, I mean, those are questions that if I had time, I would look into now. The origin of multicellularity is another one, but that one of the time, how do cells perceive time? How do they create time, and how do they perceive time? I think those are very, very interesting questions. Advice to young people is very, the world in which we live is very, very complicated. I think science is not something that you do if you want a job. I think you have to be passionate and obsessive. And I think there are good questions there. I think don't fall into the trap of simply technology development or use. Think of the questions, because there are good questions out there. They are hard, but I think there is a reward in trying to answer them, even if you don't answer them all the time.
Is that something that you advise your PhD students on, or your graduate students?
Yeah, I think these days, PhD students, they have to have a very big motivation. I think over the last few years, we are entering into a sensitive territory. I think when I started doing science 40, 50 years ago, there was not that many people doing science because the educational systems were not mass producing science majors. And I think those of us who were doing science, and even you, and I know you majored in physics and all that, we were driven by curiosity. And I can see that in your program, the way you interview people. I think today there is a lot of people, and I have sometimes when I meet students, I ask them a question that surprises them. I ask them, have you ever been bored? Mm-hmm. And they don't understand that question. And I think being bored at some point in your life is very important to find out what you want to do. I said at the beginning that I grew up in a country and at a time where we were not taught anything because there were other priorities. There were social unrest, there was a dictatorship. So I had to find out by reading, by following my hunches, what I was interested in. I think today people from very early on are drawn into getting a CV, into one thing after another. They don't have time to think. I think it's very important that you get a time to figure out what is that you want to do. Don't get into science simply because you think you're going to get a career or this is where you're schooled. Get into science because you want to answer a question or you are curious about nature.
Uh-huh.
And for that, sometimes being bored is very, very useful.
Professor, thank you for spending so much of your time with me.
Thank you, Curt. Thank you. I think you're very open-minded, man.
Oh,
you're very open-minded.